Hi, this is Alex from devstories.eu. MicroPython, Episode 2 of 7. Stop recompiling C code and flashing firmware just to test a sensor or flip a switch. You want direct control over your microcontroller without the boilerplate, and that is exactly what the machine module provides. The machine module is your hardware bridge. It translates Python code into the electrical signals that drive the physical pins on your board. It provides access to core hardware features like central processing unit frequency, sleep modes, and digital input and output. But because it sits so close to the metal, it comes with a warning. This module does not hold your hand. If you configure the wrong hardware register or write to a protected memory address, your board will crash and reboot. The foundation of this module is the pin class. A pin is a physical connection on the microcontroller that can send or receive electrical voltages. To control a basic component like an LED, you need to drive voltage to a specific pin. You do this by importing the machine module and creating a pin object. You provide the physical pin number and you define whether the pin should act as an input or an output. For an LED, you configure it as an output by passing an output constant. Once the object is created, you use it to set the state. Applying a value of 1 drives the hardware line high and turns the LED on. Applying a value of 0 drives it low and turns it off. You are manipulating the digital state of the hardware in real time from a Python prompt. Sometimes basic on and off states are not enough. If you want to dim that LED or control the speed of a motor, you need pulse width modulation, or PWM. The machine module has a dedicated PWM class for this. Instead of a steady stream of voltage, PWM turns the pin on and off extremely fast. You create a PWM object by giving it the pin object you already configured. Then you set two hardware parameters, frequency and duty cycle. Here is the key insight. The frequency dictates how many times per second the signal cycles, while the duty cycle dictates what percentage of that time the signal is actually on. If you set the duty cycle to 50%, the LED is only receiving power half the time, making it appear half as bright to the human eye. By gradually changing that duty cycle value inside a loop, you instruct the hardware to create a smooth fading effect. For advanced use cases, the machine module offers direct access to the underlying hardware registers through objects called mem8, mem16, and mem32. These allow you to read and write raw bytes, half-words, or 32-bit words directly to specific memory addresses. You do not use a pin object for this. You use standard bracket notation, passing the physical memory address you want to access, exactly like looking up a key in a dictionary. Assigning a value to a mem32 address instantly overwrites that hardware register. This is how you interact with obscure microcontroller features that MicroPython has not explicitly wrapped in a class yet. It gives you absolute authority over the silicon. The true power of the machine module is not just that it makes hardware accessible, but that it completely removes the barrier between writing high-level software logic and manipulating physical voltage. Thanks for listening. Take care, everyone.